Hello, Narnach here. Welcome back to the Human Resource Machine. Let's pick the blue guy. So, last time we left off here. I'd solved number 9, but I didn't solve it completely. And I asked you, the viewers, if you could help a bit. And actually, I got a response. So, the response was to actually start off with the outbox and then jump over it. So we jump over the outbox, after which we grab something from the inbox, and then if it's 0, we jump here, and otherwise we just jump back. I think it was something like that, and that would save 1 cycle. So let's have a look if that actually works as intended. Okay, at least it's still a correct solution. Well, the question is it faster? Perfect solution. So, thank you MyZardX for helping with that one. So, we move on to the next one. Sub-hallway. Subtraction? Question mark. I never learned that in school. Did you? Well, a good team. So, let's see. We can talk with him. Ah, cool. So, he also has some help if I get stuck or something. Useful to know. Let's see. For each 2 things in the inbox, first subtract the first number from the second one and put the result in the outbox. And then subtract the second one from the first and put it also in the outbox. So 2 minus 1 and then 1 minus 2. Okay, we can do that. Let's see. So let's see. Inbox. We grab the first number. We copy that to box 1. Then we inbox again and we do a copy to put it in box 2. And we have some jumping about just to wrap everything up. Okay, so the subtract the content of a tile on the floor from whatever you're holding. Okay. So what you're holding, minus 1. So that's the opposite of the add, which add whatever's on the floor to what you're holding. Okay. Okay, so we pick up the first item, we put it down. We pick up the second item, we put it down. So we're holding the second item. Now we need to subtract the first one. That's we can do that. So then we subtract the first one and we put that in the outbox. Then we need to copy from the first one. We subtract the second one and we put that in the outbox. Let's see if this works as expected. Okay, that seems like a solution. It's the solution even. Good, so we can move on. Equalization room. Clickety clackety. Let's finish. Sometimes some numbers are bigger than other numbers. And sometimes they are the same. Oh no, how can we know? I read about that here in this great book. Which number are you for the aspirational 0? You can borrow it later. Alright. Look. Hello world. Yay, we got comments, so we can actually mark sections. That's useful. Very useful. Hey, I actually have tabs for multiple solutions. That's interesting. So let's see. Get 2 things from the inbox. If they're equal, put one of them in the outbox. Discard non-equal pairs. Repeat. Okay. How do you test if 2 things are equal? If you take one number and subtract it from itself, you always reach exactly 0. Otherwise, it's either more or less than 0, but it will never be exactly 0. So that's the trick we're going to use now. So we take a number, okay, hello world, you can go out, I don't really need to comment right now. So we take something from the inbox. We store it in here, because we need a copy. Then we take something again from the inbox. Then we subtract whatever we have stored. Then if it's 0, we continue. Otherwise, we loop. Okay, so this is where the comments come in, I suppose. So let's see, what shall we call the first bits? We call it. Wait. We say it's a grab. Oh wow. Can't type in here. We can't. Okay, whatever. So in that case, labels are useless because I can't draw with my mouse, even if my life depended on it. So whatever. Let's hope it doesn't get too complicated. So we grab things, and if they are equal, we jump. Otherwise, we jump back. Then in this case, we do a copy from. We take the original number that we stored. We send it to the outbox. And then we jump back. Let's see. Theory is valid. Question is it efficient? It's not, and probably have to apply the same trick as with level 9. Which is that we start with this, we jump over it, and if it's 0, we actually run this, and otherwise we go back. Does this make sense? Ta-da! Okay, moving on. Level 14, maximization room. There's been a change of plans. The counting department has determined that treating all numbers equally is no longer profitable. Management wants the big numbers only. Grab 2 things from the inbox and put only the bigger of the 2 in the outbox. If they are equal, just pick either one. Repeat. You got a new command. Jumps only if the thing you are holding is negative. Less than 0. Otherwise, continues to the next line. Okay, so it's the same trick, but rather than jumping on a 0, we now jump on a negative. So we grab 2 things. That means inbox. We store it. First thing. Then we do inbox, and we do second thing. Then at least we're holding a copy of both. Then we have the second one. Then we subtract the first one. Okay, and now we start thinking out loud. We can only check if it's negative. Yeah. So if it's negative, that means that the number that we subtracted from the second one is larger. So that means the first one is larger, then which means we need to send out the first one. So if it's negative, then we do a copy from that one and we outbox it. Otherwise, we copy the other number and we outbox that one, because then it means the number was either 0 or greater, in which case we need this one. Either way, after this we need to jump back to the beginning, and after this we also jump back to the beginning. So the code should be saying. The question only is if this is efficient enough. And it's not efficient enough. So I could actually do it with 2 less commands. Okay, interesting. Well, the outbox we can... let's see, let's say if we start again with an outbox that we jump over. Yeah. Okay, so if we have this one, we simply jump over there, and otherwise we jump over there. We don't need the outbox, but we do need a jump back down there. Well, it seems like we saved ourselves one instruction. See how this, if this actually made a difference or not. Actually got less efficient. We took 1 extra cycle. Okay, so inbox there, inbox there. Then we subtract it, so we know how to judge it, and then we need to actually judge it. We need to get rid of 2 instructions. Okay, so what if the jump is negative? Also now there's the situation where this one is the thing. Well, if this was our default case. So that way we save ourselves 1 jump. Okay, so otherwise we have another situation. And we jump into the middle of here. Seems slightly more efficient. At least I took 1 instruction out. 1 more. Okay. What instruction can we get rid of? Most obvious one seems to be an extra jump somewhere. Okay, we have to skip over this bit, the copy from 0 and outbox, because otherwise we send out output that's not relevant, which is not a good thing. So this jump seems to be required. It's 1 extra step and 1 extra instruction, so it would be a perfect fit to get out. Let's see, alternatively, inbox, copy, we subtract. And then we make a decision. And there's also a jump back. So what if we did actually put things back down? So what if we took the jump out and we do revise our logic? So copy from 1 and outbox. We have the negative jump. We have a copy from 0. We have a jump back. We took out 1 jump. But now there's a flaw in the logic. Because we do a copy, we outbox it. And if we don't have a negative number, well, if we do have a negative number, we jump over and we do a copy, but we never do an outbox flush. And in the other situation, we do a copy, we do an outbox, and then we still execute a copy from, which we shouldn't be doing. So this gets all jumbled, and we probably need 2 extra jumps to make it work right. So actually having the jump in the beginning with the outbox and the copy from 0 and the jump. And this one. Seems to be more. Let's double check that I didn't mess up the order. Just double checking. Restoring it. Okay, it's correct. It's just not efficient enough. There's one instruction that's off. So I think I'm just going to leave this once again as a challenge for you, the viewers. What am I missing? It's probably obvious, like the previous one. Once you see the solution, it's hard to realize why you ever did it differently. But in this case, yeah, this is it. So, yeah, we continue onwards to the next level. I'll leave this as an exercise for the viewers. Continue to the elevator for year 15. Absolute positivity. No, wait, we have the executive lounge. Oh, employee morale insertion. Cool. More coffee breaks.
And that, ladies, is how I saved a bundle on my long-distance telephone service.
That's...
Back to work, everyone.
Doesn't sound really good. It doesn't sound like a bell. It sounded more ominous.
A massive army of machines has surrounded the city. The machines are not moving, and they are not communicating. Local authorities are investigating.
Dum dum dum. Okay, let's see. So 16 lower than 17, so we do 16 first. Absolute positivity. Aha! Positive attitudes were determined to increase positivity. And are now therefore mandatory. Smile! Management is watching. Send each thing from the inbox to the outbox, but if a number is negative, first remove its negative sign. Okay. So basically we need to return the absolute number. Interesting, absolute positivity, nice play on words. Okay, so let's see. Let's start from the beginning. We have a main loop, we have an inbox, and we send it to the outbox. That works as long as numbers are not negative. So what happens if the number is negative? Look, we have a check for that. Then we actually... Wait, let's do this other thing again. So we have the outbox that we jump over. Then we have an inbox. Then we can do some bit of pre-processing, and then afterwards we have a jump again that takes us here. Oh, there. Okay, so now we have a section here where we can remove the negativity. Let's see, if you subtract a negative number from a negative number, I remember something about that making it positive. So if you have negative 2, you add positive 2, that makes 0. On the other hand, if you add negative 2, it becomes minus 4. But if you subtract negative 2, that acts like a plus 2. Negative and negative cancels each other out, and you end up with 0. So if you repeat the trick once more, you end up with plus 2. So that's what I'm thinking about using. So let's see, this was the, if negative, we copy the number here. And then we subtract it once, and we subtract it twice. And we end up with the positive version of that number. After which it goes to the outbox. If the number is not negative, we skip the instruction, we go to the jump, and we flush it out straight. Seems to work. Eight. Actually, it's faster than the benchmark. Sweet. Okay, so let's go to the executive lounge. Oh, 17 years with the firm. That's pretty nice, right? Yes, I've always felt most comfortable with nice, cold, logical decisions. Emotional decisions are for the weak. Okay. For each 2 things in the inbox, send a 0 to the outbox if they have the same sign, both either positive or negative. Send a 1 to the outbox if their signs are different. Repeat until the inbox is empty. Interesting. So this is the numbers we can output. They're already stored there. That's good. Okay. Let's come at this from the same direction. If they have the same sign, if you add 2 positive numbers, the result is going to be positive. If you Actually, wait. What did we just do? We made negative numbers positive by subtracting it twice from itself. If we have a positive number, can we, if you subtract that twice from itself, it becomes negative. Actually, why am I being difficult? I can test if it's negative. So, we take a number from the inbox. If it's negative, then we take another number from the inbox. If it's negative, we know they were the same. Simply saying. So in that case, we do a copy from, let's see, it was 0, it was the same. And then we set it to the outbox. Okay. So if it's not negative the first time, this is going to be messy. This is going to be messy. So this is the golden path for negative numbers. If the number is not negative, well, actually this was the golden path for positive. If it's not negative, we fall through. If this is also not negative, we send out that it's the same. Yeah. Okay. So if this first one was not negative and the other one is, that means we have different signs. Which means we can act on that, because that's a problem. Yeah. So we can actually handle that case over here. That means we do a copy from the other number, because that's different signs. We do it, send it to the outbox, and then we jump back to all the way to the beginning. So, not negative, we fall through. If it's then not negative, we have reached our goal. If it's negative, then that's the different sign from this one, so we jump over and we send out a 1. So we have 2 different use cases to handle. What if they're both negative? So that's the next one. If the first one is negative, we get over here and we can do another check. Is it negative? If so, they are the same, in which case we send out a 0. So then we do a... That's the same logic as this one. We do a copy from the 0, we send it to the outbox, and we jump back to the beginning. Okay. So all that leaves us is with the other situation. And that it's different. Because we jumped in here the first time because we were negative. Then if we check for negative and that's not the case, then we have once again different signs. Which means we have to emit the number 1, which we do by copying the 5, outboxing it and jumping back. So this is a lot of jumping. I have to say, this way of describing the solutions, if it gets any more complicated than this, oh god, that's gonna be interesting. Management expected a 1, but you outboxed a 0. Oh, step back and debug. Okay. So let's actually go through it slowly and see what went wrong. So we had a 5. What? Something went weird with the inboxes. Ah, duh! We never read the second inbox. We just made decisions. So if it's negative, we jump over there, and we need to read the inbox, and then we do a jump if negative. Okay, that makes more sense. So the solution idea was correct, I just needed to actually read the inbox. Okay, fair. And this one was slightly suboptimal again, creatively. It probably has something to do with putting the emitters at the beginning rather than at the end. Similar solution as the previous time. So let's actually do it in the second tab, because I really don't feel like I'm doing a working solution. So we jump over one thing to emit. Well, actually, what we can do here is we copy it. Yep. Then we open up the next tab. We paste it, and then we can start messing about. Okay, so copy output, and then we just fall through to the inbox things. We have another one with the copy 5 and outbox. We can probably save this outbox by just putting a jump in here. And we probably want a jump over this to the beginning. Okay, so we have our output signals thing set up, so we can just jump to whatever we need. Time for logic. And we have the main jumping thing. Actually, I don't think we actually need this, because there is just so many decision making going on. So we read the inbox. If it's negative, we jump over to the next bit that also reads the inbox, which then has a hard jump. jump after this one as well. Okay, so this is a combination of if-else statements. So, redo the logic that we had before. So if the first number is negative, okay, we jump over. We read this one. If this is also negative, that means we have the same sign. If it's the same sign, we send out a 1, which is stored in 4. So we jump over here. Okay. Other situation. What if it's not negative? We jump through. If this one is negative, that means we have different signs, which means we send out the number 5. Okay. So what if this is not a negative and this is also not a, this already points back. We have a jump. Not a negative, not a negative. That means it's the same, so we emit a 4. Okay, final situation. We had a negative because we jumped over. We read this. If it's a negative again, it's the same. Otherwise, it's different, so it's a 5. Okay, this ought to be the same solution, but structured in a different way. That's slightly more efficient. 28. And we still need one less jump or something. Use 12 or fewer commands. Okay. Yeah, there's 13 in here. Okay. How do we optimize this? One less instruction and then something else needs to run twice because we have the same number of instructions that we can hit. Okay, inbox. Negative jump. Here we jump over. See, negative. This one needs to read the input, so that has to happen. And this jump also seems to has to happen. Okay, here's the. We have an inbox with a jump negative and a jump. We have an inbox and a negative and a jump. Is there anything in the logic that's similar that we could maybe reuse the jump situations? No, since they are opposites. Okay, we need this final jump here because otherwise we fall through to the inbox. That's also not a good thing. I am not seeing it. What is instruction? Let's see, what does the... Let's see, tell me more. Basic Boolean logic operation. Called XOR. Exclusive OR. Armed with this new information, you may research independently if you like. Okay, so basically they tell me to Google it. I know the basics of how exclusive OR works, but... it's hard to structure things like this. Hey. I think I'm leaving this once again up to you, my dear valued viewers, as optimization viewer for the watchers at home. So we made it up to executive lounge level 17. That's pretty good progress. Wait. We ran the maximization room. Why is there no score for this? Run. Go. We did this, right? Oh wait, we had reverse stats. Ah, this was also an exercise for the reader. So there's 2 exercises for the reader, 14 and 17. I'd be interested. I would be interested to know how you did it better and how you actually made it with perfect scores. So let me know. Leave a comment below, and then I'll see you again next time. Thank you very much for watching, and bye bye.